I want to talk a bit about testing, specifically TDD. A question that comes up often is TDD good? Should we be doing it? And quite often the answer from zealots is yes, you should always do it. I disagree. First, TDD does not solve all problems. It's a good tool for a certain set of problems in a certain set of languages. Specifically, languages with weaker type systems, TDD is great for because the type system can't protect you from things. But it also only works on a limited number of problems in the first place, and there are the zealots that say, no, TDD works for every problem, always, every time. Don't listen to them, they're idiots. Sorry, idiots, you just are, that's the way it is. If you cannot tell me the downsides of a tool or methodology you're using, you don't know your tool or methodology. No matter how great a tool is, no matter how great something is, it always has some downsides. It always has some compromises. If you don't know them, you don't know your tool. So leave me alone, please. Now, let's define what TDD is first, right? And it's a full book, so I'm going to be incredibly overgeneralizing and simplifying it. But TDD, in a nutshell, is just it wants to guide. That's not how you write guide. Guide the development of our code through tests. To do that, it uses some tools. One is called the red-green refactor. And obviously we should write tests first. Write test first. I don't know why I'm all capitalizing those, but it doesn't matter. So what does any of this mean? So write test first is more or less self-explanatory. I'm going to use fizzbuzz because it's a trivial example. We're going to write the test first before we write our code. Obviously, we need to make the compiler happy at the very least, so otherwise it's just not going to work at all, because we can't run the test if the compiler's unhappy. And then we run the tests, and this is the red-green refactor. The test should fail. Then we adjust the code with the least amount of effort required to satisfy the test, while also satisfying all previously written tests. At some point of time, there is the need of generalization, where we look at our code and we detect a pattern and we say, okay, we could rewrite this function to still satisfy all of the tests, but in a simpler way or in a more general way. And that is the step that doesn't work. Well, there's a few steps. Anyway, that's how TDD works. So as an example, let's just do it with fizzbuzz. So let's say test when x equals null, then we want to return null, right? All right, let's define how fizzbuzz works. If x is not divisible by 3 or 5, then return x. If x is divisible, I don't actually have to cut out that email notification. No, I don't. If x is divisible by 3, return fizz. If x is divisible by 5, return buzz. If x is both divisible by 3 and 5, return fizz buzz. Right? That's the test. Now, I'm not gonna get ahead of myself. I would not use TDD to develop this. Ever. I see no reason to. For most algorithms, I wouldn't use TDD, to be honest. But to admit my bias, I don't like TDD. But let's move on. So we're going to expect x, fizzbuzz here of x to be 0, right? And x is 0. And we run a test. It should be read, it fails. And then we do the least amount of work necessary. And that is to just return. Actually, this is, if we're going to be really strict with it, we should return first just this. Then run the tests again. It passes. Let's ask the next question. Next question is when it's 1, for example. Return 1. And I'm going to... Nah, I'm gonna leave it like that. So we then run all tests. The new test fails. And then we can do something like... okay, so if x equals 1, return 1. At this point, I don't know if you're supposed to generalize or not, but many examples like doing this. So this is how I would go along if I'd stick to it properly. And when we ask the next question to, maybe now we're allowed to generalize it into just... this form here. Oh, sorry. I forgot to run the test already, because I don't need to run the test to see that it's right. Let me copy this. And I hope you can see kind of why I don't like this. This is a trivial example, but which steps do you do? Which steps don't you do? When do you do them? Anyway, the generalization works now. That's nice. Let's add the case 3, at which point we expect this to come out. And of course this fails, and then we can do if x equals 3, return fizz. And I hope you can see how this takes a very long time to describe our problem with these examples and the red tree. To get anywhere. Whereas, like, I've been doing this for what, 5 minutes? If I'd run fizzbuzz, I'd just do it like this. We get a number in, string out. I read the requirements. It's simple. So if x mod 5 equals null, unequals null, not divisible by 5, and x mod 3 unequals 0, return x. Just reading the requirements straight up. And then we can do if x is divisible by 5 and divisible by 3, return fizzbuzz. And we can check just for the 5, which was fizz or buzz. I think I buzz. Yeah, I made it buzz. And if it's just divisible by 3, return fizz. Now we can reorganize this. We can move this down here. remove a statement. Because if we know if this one it doesn't solve it and this one fails, then we are already in that case. We can also simplify this because we can realize, well, that's the same thing as taking mod of 15. And we're done. This is correct. We could now write the tests for FizzBuzz 2. And it would pass them all. And I can do that right out of the requirements. And I can even enforce the return strings with the typing here. Whatever. Let's continue to this exercise. I'm just gonna skip ahead to 5 because 4 is not gonna be interesting. We say this should return buzz. And I'm not even gonna bother running it, and I'm just gonna go to 5 buzz. And I don't have a discipline to do TDD properly because of this. And if we run this, it passes now, of course. If I write this here. And then we can start working with parameterized tests. For example, we could do choose multiple numbers here instead of just 3 and put them in there. But then we'd need to pay attention to this case here. Because we need, when we write the test to detect the fizz case, we need to make sure there's no buzz in it. Which means we already know the generalization to write that test. And that's a huge problem with TDD. And that is, it makes 2 assumptions. Let's get to the point. Rather late into the video, but assumptions. Assumption A, the problem can be fully described and discovered via tests. That's the first assumption, and that's already not true for a lot of cases. And the second assumption is the author can know the right tests. Can know or discover the right tests and their order to. And their order from A. And the goal is to find the solution to the algorithm. To solve the issue, we need to A, be confident that it can be fully discovered with tests. This doesn't work for a lot of mathematical data structures, for example, or like, for example, you wouldn't be able to discover many sort algorithms with it. Merge sort, forget it. You could input-output sorted lists, but you'd just get a sorting algorithm out at best. You wouldn't get an optimized or performant algorithm. Of course, you could partition it and have a merge part and the split part and test if it calls the things, but that's not TDD anymore. And we already have knowledge of how the algorithm should be in the end. And that is obviously, if we already know, then we don't need to bother to discover it. Anyway, what did I want to say? Right. So this has the big problem that to discover any algorithm through the asking of the right questions, we need to know so much about the algorithm that asking these questions, in my opinion, becomes pointless. We could just solve the problem in the first place. We're not discovering the problem anymore. Now we could write the algorithm, as far as we understood it, write tests, and then add more tests. But that's not TDD anymore. Do I have a point? Not really, I just felt like ranting about something. And I hope this short exercise showed just how ridiculous it can get. Now, there are genuine applications, and that is, for example, if you're testing against an API and you have acceptance criteria, you can describe them exactly how they are and fulfill them. That's a good application of it. But I like interesting problems. And by interesting problems, I mean problems where you have to think really deeply about what you're doing. Maybe pick up my whiteboard marker, go to my whiteboard, and actually scribble something on it. And TDD just doesn't work for these problems. For that specific type of problems, it doesn't work. Yeah, no, they don't have a point. Just wanted to rant. See you.